looking at forward and backward scanning. We use forward and backward scanning to actually work out the earliest start time for each section or each activity in a project. So let's have a look at it. So here we have all the activities in this network diagram. We've got the duration of each activity already on there. So what we're going to do is we're going to use forward scanning to work out what the earliest start time is for each of these. Now, the way we do this is for each activity, we are going to draw a box. So I'm just going to draw a box like so for each activity. Now, because we've got A and B coming off this one, we have to do two boxes. So I've got an A box and a B box. Then when we get up to this point here, this vertex, we only have C coming off it, so I only have to do one box, and so on and so forth. So I'll just do those boxes to start off with. Hopefully I'll make them big enough so I can actually write in them without messing things up. And then G, we have that one, H, and then the finish. So we do have to include one for the finish. Okay, so there are our boxes. So let's fill them in. So the earliest start time. So what we do is we have a look at it and go, okay, what is the earliest start time for A? Well, hopefully for A and B, it is fairly straightforward and obvious that they start at time 0. So that is the earliest time they can start. So now we'll head up to C. Now, C can only start when A is finished. A is going to have a duration of 8 days in this particular case. So C can only start after 8 days because that's the only time that A is finished. And we'll keep along that track. C takes 1 day to finish, which means E cannot start until after 9 days. Once again, I'll keep following that down to G. E takes 3 days, which means G cannot start until day 12. And then moving along to the next one, G takes 2 days. H obviously can't start till 14. And that means that the finish would be after day 15. Now, there is one small issue with this that I haven't brought up that's not really going to matter at this point, but we'll have a look at it when we get to it. So we'll now go the other track. B obviously can't start until 8 as well. That is the earliest time it can start. Am I going nuts? I am going nuts. It says 6. Draw that line. B takes 6, so D can start after 6, sorry. So there's that 6 there, not the 8, which is up at A. There we go. All right. So what have we got now? Then D, obviously, that takes 2, which means we're going to add that to the 6. And you would think that we're going to get an 8 there. Now, this is where the issue that I was talking about comes up. Activity F. Activity F has 2 precedents. It has 2 preceding activities. It cannot start until C and D have finished. Now, if I were just looking at D, I was at 6 days there, and then I add another 2, so that would be 8. However, if I look at C, up here, C couldn't start until day 8 had finished, or that was its earliest starting time. And, sorry, my box is gone. It couldn't start until day 8, and then it takes 1 day. So if you're looking at C, it couldn't start until 9. E couldn't start until 9 because its earliest starting time was 9. Now, F is dependent on C as well. And so the earliest starting time after C is 9, which means the earliest starting time of F is also 9. Now, that may be a bit weird for you at the moment, but you followed this one and then this one, which you think would get you to 8, but F also requires this. It also requires that dummy activity from C. And then C was at 8, and at the end of this one, it's 9. So the earliest starting time, even if you had finished this task, you'd finished that after 8 days, you still had to wait until that activity, until the activity coming from C. You had to wait until C had finished as well as D. So D had finished after 8 days. So F could have started, but it also requires C, and C is not finishing until 9. And so that's where that came in. Now, this also applies when you get to this one up here. F only takes 1 day, and its earliest starting time is 9 days. So if you add the 1 to that, you would expect it to be 10. But G requires both E and F. Now, F might have an earlier starting time. F might have given it an earlier starting time of 10, but we are also waiting for E to finish, and E wasn't going to let it start until 12. So even though you thought it might be 10, it cannot be. It has to be 12 because it's coming down that track as well. Okay, so that is the earliest starting time. We've got, then you follow on, you get to the 14, you get to the 15. Okay, now we are going to do backward scanning to get the latest starting time. And from memory, yeah, we're going to be using these same numbers, but we will go on to that one and we will go back. And that's why I've left these second boxes. The first one was for the earliest starting time. The right-hand boxes are for the latest starting time. So we'll do that in a couple of seconds.